This is a short video on how to use the Phoenix controller's automatic approach for AM mode, to do the final adjustment of height before imaging. We prefer this approach because it is fast and safe, initially running the Z motor at full speed until air damping between the cantilever and sample starts to drop the amplitude. As we covered in the previous video, we start by doing a thermal tune to calibrate the cantilever and find the resonance of the cantilever. This information is automatically populated in the AFM software, and also saved as metadata in the image file. A minimal rundown of the controls. The Start Sweep button starts the frequency sweep. The Zero Phase Control automatically shifts the phase of the drive signal to bring the lock-in amplifier phase to 0. The Shaker Drive Amplitude Control. The Deflection Signal Programmable Gain Amplifier Setting. The Plot Amplitude Unis button selects between normalized units and nanometers. Below this on the left are the Z motor controls. On the Z monitor tab on the right of the screen, we have 3 graphs. The top plot is the normalized amplitude signal and the set point versus time, the middle graph is the phase signal, and the bottom graph is the Z signal. Let's start over and explain the procedure. We run a frequency sweep first to determine how to adjust the drive and deflection gain. Notice with the default PGA setting of ×4, the amplitude is less than half of the full range on the normalized amplitude plot. We can kick the PGA up a notch. We don't know how much the amplitude will drop during the approach, and if the amplitude is very small, the approach algorithm may be confused by the noise from the motor vibrations. In this case, I will start off with the amplitude of 80 nanometers and we can adjust it before imaging. A short description of the approach algorithm. There are 3 stages to the approach. The first, the Z motor is run at high speed until the amplitude drops by 3%. The second, the motor speed is lowered and continues until the amplitude drops another 7%. The third, a sewing procedure is started, where the Z servo is turned off, withdrawing the sample. Then the Z motor is run a set number of steps. Then the Z servo is turned back on. If the Z servo reaches the set point but the phase signal did not jump, then it didn't find the surface. The set point is lowered and the sewing procedure continues. If the phase jumped when the servo was engaged, it found the surface. It may go a few more cycles to bring the sample near the middle of the Z range, before stopping. The auto approach is now complete. We can see the Z servo is near the middle of its range. To adjust the amplitude, now turn off the Z servo. And do another frequency sweep. Adjust the drive amplitude down. The last time imaging this sample I had good results with a free amplitude of around 30 nanometers. Thank you for watching.